Alright, hello everyone, welcome to the video. Today we will be discussing NTP. NTP stands for Network Time Protocol. What is it, you ask? Well, it is a protocol that is used to allow network devices to synchronize their clocks with a central source clock. So, we will be implementing NTP into this lab today. We have three routers here, a hub router, two spoke routers. We're going to configure this hub router as the NTP server and these two spoke routers as NTP clients. So let's get started. Let's go to the hub router, and just a disclaimer here, let me tab this out of the way. NTP takes a little bit of time to fully synchronize the time between devices. So best practice is, if you have access to devices, like say these are all three of these routers are in the same building, they just happen to be in the same building, you can manually set the time on the router, on each router. Say if this is the hub router, this is the NTP server, you can set the time manually. And how you do that is do clock, actually it's config t, do clock set, and then mark it out. You set the hour, the minute, the second, and then it'll have you configure the day, month, and then the year. So if these three routers you're trying to synchronize are in the same building or within access, you can set each time within as close as possible to each other, so that the synchronization time doesn't take so long. The time that it takes to synchronize with NTP can take anywhere between 10 and 15 minutes, depending on how far apart the times are. So let's just see here how you see the current time on the network device is do show clock. And then so there we see it's 10:50, 42 seconds, July 17th, 2023. So if I had these other two routers, I could go ahead and the first thing that I would do in trying to set up NTP would be to set these two spoke routers as close to that hub time as possible, just so that it doesn't take as long to synchronize. So that being said, I'm doing this in Cisco Modeling Labs, or CML. This is a virtual lab, as you can tell, and just from previous experience and previous times setting up this lab, the synchronization time takes a lot longer on here. I'm just guessing because it's a virtual environment. The beginning part of this lab I have pre-configured. It took about a half hour for it to synchronize, and that was even with me setting the time on the hub router at and then the spoke router is not too far behind it. So luckily there's not too much that goes into NTP. The bare bones NTP commands are pretty simple. Let's just I'll show you that right now. So like I said, well, first things first, you just have to get Pingability, basic connectivity between the hub and spoke routers. Let me show you the interfaces that I have configured on here. Do show IP interface brief. So here, and then we'll do show interface description. So here we have gig 0/0 configured for 192.168.1.254, and that is the link to spoke 1. Then again we have gig 0/1 configured with the IP address of 192.168.2.254, and that is the link to spoke 2. So let's go to spoke 1. What do we have configured for spoke 1? We have gig 0/0 configured as 192.168.1.1, and that is the link to the hub. It's linked to the hub. And we have do show. Let's tab this out here. Let's get rid of all that nonsense here as well. There we go. Alright. what do we have configured here? Do show IP interface brief. We have gig 0/0 configured as 192.168.2.1 as it's linked to the hub. Let's just verify pingability right here. So do ping 192.168.2.254, which is the hub router. We can ping that, and let's also ping the hub from the spoke 1 router. Do ping 192.168.1.254, and we can also ping it. So we have basic connectivity, basic pingability between these routers, and that's the first step in setting up NTP. The second step is what I had already configured, as mentioned before. Let's just do a do show NTP. Actually, it's a pipe command, so do show run pipe section NTP. So I didn't really, there's not much that you have to configure on here on the hub router for bare bones NTP configurations. I did clock set, I set the time on it. I did clock calendar, and like I said, this is going to be the NTP server. So I input the command clock calendar valid, make sure the calendar time is authoritative, which is what we would want for an NTP server, and then made it NTP, let me question mark this out so you can see the explanation, NTP master. So it acts as the NTP master clock. Then I gave it a stratum of 1 because it will be the NTP server. So NTP specific commands do show run pipe section NTP is pretty much just this one command, NTP master, and then the stratum value of 1. So let's go to spoke 1. So let's see what we have configured for NTP over here. So do show run pipe to section NTP, and here we have our 2 configurations for NTP on the spoke router. We have NTP source gig 0/0, which is our interface going to the hub router. Then we have NTP server 192.168.1.254, which is the physical interface facing spoke 1 on the hub router. So those are the 2 NTP configurations needed on spoke 1. Going to spoke 2. Let's do show run pipe section NTP. And again, pretty similar. NTP source is our physical interface to the hub. NTP server is the hub's IP address facing spoke 2. 2.254 is that IP address. So very basic commands, very simple commands for bare bones NTP hub and spoke. And like I said, it took about a half hour to fully synchronize between the hub and spoke routers, even though I did the clock set and set the time pretty as close as I could to each other, almost exactly the same. So what are the verification commands for NTP? Since this is already, as I mentioned before, this is already synchronized, what are the verification commands that we can do to prove that we have NTP up and running? So first things first is do show NTP status. So what we're looking for here is clock is synchronized. We see the stratum value, and the hub it will be unique because it is the NTP server, so it has the stratum value of 1, and the stratum value can be from 1 to 15. 1 being the best, 15 being the worst. Anything above 15 is unusable. So if for some reason if you misconfigure this or if you're not synchronized yet, you'll see that the stratum value will be 16, and that means it's unsynchronized, it's unusable, it's not configured properly or configured yet, and that's what a stratum of 16 means. That's what the stratum values in general mean. So stratum value of 1 means it is the trusted, it is the authoritative time. The stratum value means the closer, the lower the value, the closer you are to the true clock. And we configured the hub router as the NTP server, the true clock, so it should have that stratum value of 1. And the reference is local because we are the NTP server. So those are the verification commands for that. Let's also do show NTP associations. So we'll see here. This is kind of our like a peer neighbor. This kind of shows our neighbor almost in NTP. This is our association or kind of NTP neighbor. This address. This is our NTP association, has a stratum value of 1. I believe this IP is an NTP server of some sort, maybe some sort of atomic clock, but this has a stratum value of 0, which doesn't exist. But this is just what it looks like when you configure the NTP server as the hub. It has this IP address, stratum value of 0, and again, this is our association, so this isn't reflecting us. This is who we're associating to. This is who the hub is getting its time from. So here we have it here. The poll value is how often the time is synchronized and updated. I believe that's in seconds. So that is the verification for that. The do show NTP status and do show NTP associations. Let's go to spoke 1 and do the same thing. Now on the spoke routers, it'll make a little bit more. It'll look a little bit more. It'll make a little bit more sense because we're peering to pointing to the hub router as the NTP server. So let's do show NTP status, and again we see the clock is synchronized. We have the stratum value of 2, and the stratum value. Another explanation that I can give for it is it's kind of like the hops. How your stratum value is how many hops away you are from the true clock. So our true clock is the hub, and we are the next hop. So we are the stratum value of 2. It's pretty simple to understand. Our reference is that hub router 192.168.1.254. So and as you saw over here, it's different from the hub command when it said the reference value is local. It's the reference value is itself. Our reference value now is this hub router because we're referencing it for the time. So let's do the do show NTP associations, and like I said, the hub side command. The hub side part of this is kind of weird. When we did the NTP associations, it had this weird IP and stratum value of 0, and it just looks like that. On the spoke routers, it makes a little bit more sense because we're peering to the actual hub. This is our association, our almost neighbor, if you will, that 192.168.254. The IP address on the hub. It's the reference clock for the hub is local, stratum value of 1, poll is 64, and again, I believe that is in seconds. That poll value means how often the association is updated or checked. And let me explain these little symbology down here. So if for some reason, if you did show NTP status and it says unsynchronized, and you do show NTP associations, you'll see that this address here, your association, would have this squiggly line, this configured line there. And if it's unsynchronized, it would just have that squiggly line. What we're looking for is to have that line and then also this asterisk, which means it is our system peer. So we have the asterisk and that line, which means we are good. Some more NTP verifications. A good one is debug NTP packets. Do debug NTP packets. and it'll take a second to cycle through. This is a really good command to see kind of the traffic that comes and goes between the NTP associations. Just give it a second to pop up here. It might take a second. We can leave that running. Let's do a show NTP packets. Do show NTP packets, and this is kind of a similar command. This is just seeing that you have traffic flowing to and from your NTP associations, and we see here the NTP in and out is doesn't have to be a specific number, just so that it's not zero. We see that traffic is being passed in and out, and same thing as if traffic was coming out. It'd be same thing if the number, if this was zero and then the NTP out packets were a different number than zero. We want both of these to have a number on them, so that we can see that traffic is flowing out and in, not just that we're sending packets out and not receiving any with the value of zero. And then now we see this debug NTP packets come up. So this is a really useful command. Message sent to the hub router 1.254 from our interface 0/0 with the IP address of 1.1. We received a message from the hub on that same interface, and then it should cycle back again. Yeah, it'll just keep repeating this of message sent, message received. Yeah, it'll just keep repeating this cycle, and that's what we want to see. That's just the updating. That's just a refreshing resynchronization of the association that you'll see there. So let's just turn that debug off. Do undebug all. Boom. All right. So that is that. That is the bare bones NTP config, and let me show you on the spoke to router as well. Do show NTP status. Again, synchronized stratum value of 2, because we're the next hop from the hub router, which is a stratum value of 1, and our reference is that physical interface to the hub router 192.168.2.254. Let's do the associations command, and then here we see our association, our neighbor almost, is that 2.254. It's referencing its local clock, stratum value of 1, O value of 64, and we are good. So that is like I said, the bare bones NTP configuration. But as always, let's take it a step farther and do some additional NTP configurations. Let's do it. What if these? Let's say all three of these routers were in a VRF. Let's add those guys into a VRF real quick. Let's do it. Let's go to this hub router, and we will say IP VRF lab. Enter. Description for lab. Route designator 1099. So what happens if you want to implement NTP but you have a VRF configured on your routers or between your routers? Well, I'm glad you asked that. I will show you right now. So we have configured the VRF on the hub. Let's apply that VRF onto our two interfaces. Let me apply it gig 0/0 IP VRF forwarding lab. And as you already know, once you apply VRF on an interface, any kind of an interface, it strips the IP address or IP address configurations on that interface. So let's reapply the IP address, IP add 192.168.1.254, 255.255.255.0. So there we go. Exit. Let's apply it to gig0/1 IPVRF. Actually, let me save some time here to show run interface 0/1. Think smarter, not harder, folks. Let's copy paste that. Interface gig0/1 IPVRF forwarding lab. Took that IP address off, but we had it copied and pasted because we're smart. Exit. Let's ping again, just to verify. Well, we can't ping now because this side's in a VRF and this side's not. So let's add these guys into a VRF. Go on spoke 1, create the VRF, IP VRF lab description for lab. Route designator. I guess we wouldn't really need a route designator in this situation, but we like to go that extra mile here. Alright, exit. Let's apply that VRF onto the interface, and again, let me copy the IP address beforehand so that I do not have to type this in again. IPVRF forwarding lab. Boom. Let's verify pingability. Do ping 192.168.1.254, and we have to ping it through the VRF. Fooled you guys. We have to ping it through the VRF because we are in the VRF now. Alright, that regular ping should fail. To ping VRF lab 192.168.1.254, and we have a successful ping. Let's go over to spoke 2 interface. Again, copy that IP that is configured on there currently. Interface 0/0 IPVRF forwarding lab. I have not configured the VRF yet, but don't worry. Don't worry, we will configure that. Lab description for lab designator 10. Exit interface 0/0 IPVRF forwarding lab. Let's paste that IP back on. Boom. Alright, let's ping VRF lab 192.168.2.254. Oh no. What have we done? We missed a number. Alright, let's come here. 2.254. There we go. Perfect. So now we have the VRF configured on each router, and we reestablished, and the interfaces going on the important interfaces, and we reestablished basic connectivity and pingability. So what do we have to add now that these routers are in a VRF? How do we have to alter NTP in order for it to still work? So good thing is, again, it's a pretty simple command, and it only needs to be applied on the spoke side routers. So let's see here. Let's do show run pipe to section NTP. So again, we just have these simple two commands, the NTP source and NTP server, and we will still have these commands just with a slight alteration, and it's with this second command here, the NTP server. So I'm just going to do a no NTP server. Copy paste that. No NTP. copy and paste it. Let's do a no NTP server, and then I'm gonna reconfigure that right now. NTP server, and this is the unique part. We just put VRF and then the name of our VRF, which is lab, and then you put the IP address back on there, 192.168.1.254. 2.168.1.254. Boom. Then that is the only configuration that we needed. That is all that we had to change, folks. There we go. NTP source, NTP server, right here. Let's save this real quick. Let's go to spoke 2, and again, get these simple, super simple configurations up and running. Do show pipe to section, NTP. Oh, NTP. That's not it. NTP. Go. Let's copy paste this guy. Boom. NTP server VRF, the name of our VRF, 192.168.2.254. Boom. NTP server VRF lab. There we go. Verification, show, run, pipe section, NTP. NTP source, gig 0/0, NTP server, VRF lab, 192.168.2.254. So, we put everything in VRF. We added the VRF, we made the VRF additions to our NTP configurations. Let's see how, and BGP is down, which we don't even need BGP for this, but it's down. It's not, it doesn't matter right now. But NTP, let's see if it still works. So do show NTP status. Synchronize, stratum of 1, references local, awesome. Do show NTP associations. There we go, we're still good. We are still good. Status. Synchronize, stratum of 2, references 192.168.1.254. Associations. And we still have that association with the hub. Let's go to spoke 2. Show NTP status. Synchronize stratum of 2, reference 192.168.2.254. Associations. The address, the reference clock is, and we just have this association with the hub still. So that's great. So we added the VRF to this topology, and then we just made a slight modification to our NTP commands so that we can still enjoy the benefits of NTP with a VRF. So let's take it one step further with our NTP commands, and that is with authentication, so that we can get, we know for sure that we are getting NTP updates and packets from only people we trust, people that we can trust and know will not lead us astray. So this is the complicated part, but it's not too complicated. So let's dive right into it. Let's go to the hub router, and luckily with these commands, we have to add a couple things, but they're not too involved, so that's good. So hub router, right? NTP authenticate. Boom. NTP authenticate. NTP trusted key 1. This is for the spoke 1 router. NTP trusted key 2. That's for, you guessed it, spoke 2. NTP authentication key 1. And this is MD5 authentication, MD5, and then our password, spoke 1 password. This is for spoke 1 if you haven't guessed it. And then same thing, NTP authentication key 2 MD5 MD5 authentication, and our password spoke to password. Boom. And that is the extent of the authentication commands we have to configure on the hub. Let's do a verification real quick. View, show run, pipe to section, NTP. So there we see it right there, and we see our passwords were hashed. NTP authentication key, MD5 hashed, authentication 2, MD5, NTP authenticate, trusted key 1 and 2, and then NTP master. And that is with all the stuff that we just configured, right? Bare bones, VRF, and now NTP with authentication. This is it for the hub router, at least for the commands. It's not much at all, not much to remember, but it's just something you gotta just be familiar with. But once you're familiar with it, the commands are super simple. It's a very simple process, but it's a very useful protocol, especially if you're doing SERP-based authentication or you're dealing with essays. Very, very useful. So let's save that real quick and let's hop over to spoke 1. NTP authenticate. NTP authentication key 1 MD5 and that password that we configured. Spoke 1's on and on the secret spoke 1 password, NTP trusted key 1, and we will have to there is one reconfiguration we have to do show run pipe section NTP. It's with this server command again, so it's pretty much the same. We just have to add a little bit of something, so we have to delete it first. So no, let's paste that, add Larry, enter, paste it again. We just have to tack on something to the end here. This key, our peer authentication key, and then you guessed it, our key is 1. Boom. Let's do show run pipe section NTP. And for the spoke router, the bare bones plus VRF plus now authentication NTP commands, again, not that much, not that hard to configure. Our authentication key that is the same as on the hub, NTP authenticate, that trusted key command, source, and then that updated NTP server command with our what did they say up here? Our peer authentication key added on there so that we can trust the hub again. Alright, let's go to spoke 2. Pretty similar configurations. Config key, NTP authenticate, boom, NTP authentication key, MD5, MD5. Oh, I need to put the key. There we go. Oh, oops. And then MD5. That's why it's important to tab out, folks. You never know if you're in the right until you tab it out. MD5 spoke password, NTP trusted key of 2, and then again we have to redo that server command, do show run pipe section NTP. Have to redo this server command and just add on something real quick. So no, paste it again. NTP server VRF lab 1 and 2 wants to say 2.2.4. Then we just have to add our peer authentication key of 2. Boom. Save that, bad Larry. And then I'll show you the NTP status. Nope, I'll do show run pipe section NTP. I'll show you our final configurations on spoke 2. And again, not that much. Our authentication key, NTP Authenticate, our trusted key, our source, of course, and then the NTP server command with that added pure authentication key on there, since we're doing NTP with authentication. So let's just verify real quick. Do show NTP status synchronized stratum of 1 references local. Let's do the associations. Still good. Come over here. Do show NTP status synchronized stratum of 2 references 192.168.1.254. Let's do associations, and again we still have that association, that neighborship with the hub, at least to spoke 1 side. Boom. Let's go to spoke 2. Do show NTP status synchronized stratum of 2 references 192.168.2.254. NTP associations, and this we still have that association or neighborship with the hub. So folks, that is the end of this lab. That is NTP. We covered bare bones NTP, we covered NTP in a VRF, and finally we covered NTP in a VRF and with authentication. So great job, guys. And I will just say, any of these concepts that I cover in these videos or my previous videos, if you want more information, or if you want to dive deeper into NTP or any other protocol and how it actually works, of course you can Google, you can go to the Cisco. Cisco has lots of resources, just forum pages, or just straight just pages and pages and pages of explanations for some of these protocols. And of course there's lots of other YouTube videos that from very qualified people that can give great in-depth explanations of these protocols, and maybe how they interact a little bit differently than interact on a deeper level. I will just say networklessons.com, that is a great resource as well. It is a subscription, but it's a great resource. All their lessons are super simple to understand. They're taught in plain English, as the slogan goes, but they're super simple, super straightforward, and they have helped me a lot with these labs and helped me to understand these concepts. And best part is, their labs, they include their labs, and they're copy and pastable, so that you can copy and paste it in your own lab, see a living, breathing lab, and you can break it, mess around with it yourself. This isn't an endorsement, it's just a tool that I've used and that I've benefited from, as well as Cisco modeling labs, so that you can do this sort of thing at home. Not everyone might have the time or the money or the resources to be able to configure on actual gear. That's the best option, is to configure on best gear, but this is the second best. And guess what? You can do it in the convenience of your own home, on your own time, on your own schedule, and you can learn and become a better network administrator every day of the week. All right, thanks guys for watching. Please be sure to subscribe, thumbs up the video, and I'll see you in the next video.